Welcome back to our flipped chemistry classroom. We've spent a lot of time over the last couple of weeks going over some mathematical concepts, reviewing some basic science, and now we really start to jump into the meat of chemistry. And so first thing we're going to talk about really is what is chemistry? And the short answer to that is that chemistry is the study of matter and all of the processes that that matter undergoes. So it's really important that we are able to define matter and then also to describe matter. So first, a quick review. What is matter? You may remember this from an earlier science class. And we define matter as anything that is made up of atoms, has mass, and takes up space. So everything around us is matter. The air, our friends, the physical objects around us are all made of matter. And so chemistry is really the study of that matter and the study of the processes that matter undergoes. And so we're looking at that microscopic world, that nanoscopic world, and trying to understand those processes. So when we study matter, there are a few things that we study about it. We're going to study its composition, meaning what is it made of? We're going to study its structure. Now that we know what it's made of, how is it put together? We're going to study the properties. So what does that composition and structure mean for how that particular piece of matter behaves? We're going to study the processes that matter undergoes. These may be physical processes like changes of state, or they might be chemical processes, those things we call reactions. And as part of that, we're really also going to be understanding and studying the energy changes that go along with those processes. So one last time, we're understanding those microscopic interactions that explain our macroscopic world. So let's jump in and start talking about some of the ways that we describe matter. So one of the first things that might spring to mind is that we describe matter by talking about what state it is in. And so you're all familiar, I'm sure, already with 3 states of matter. We're going to add a 4th and a 5th state of matter that we'll talk about in chemistry class. So first, the 3 that you're really comfortable and familiar with. When we talk about a solid state, we are talking about something that has a definite volume and a definite shape. The particles are in fixed positions. They have very limited movement. We talk about only vibrational movement, no rotational and no translational. And of course, a liquid has a definite volume, but it does not have a definite shape. The particles are close together, but they're not in fixed positions. So they can move and slide past one another. This is what gives liquids their fluid properties. They can flow. They have a definite volume, but indefinite shape. That means that a liquid takes the shape of its container, but doesn't expand. A gas, our 3rd form of matter that we're really familiar with, does not have a definite volume nor a definite shape. So it not only takes the shape of its container, but it expands to fill that container. The particles in a gas are very, very, very far apart from one another, maybe 1/1000th as dense, so 1,000 times farther apart than the particles in a liquid or a solid. And then, of course, the 4th state of matter that you may have already heard of is called a plasma. So this is an ionized phase of matter. It happens at extremely high temperatures and usually is found on the sun. We also take advantage of plasma for many functions of our modern life: fluorescent bulbs, plasma TVs. And then the 5th state of matter is called a Bose-Einstein condensate. This is a phase of matter that's found as we approach absolute zero. It's considered a superfluid. It does flow in the same way that a liquid does, but it's extremely cold, so it's extremely dense. And it actually all starts to behave almost in a wave-like manner. All right, let's talk about, so we've talked about our phases of matter. Let's talk about some properties of matter. And when we talk about properties of matter, we're going to divide them into 2 kind of categories of those properties. Physical properties are those properties that can be observed without changing the identity of the substance. So we can look at it, we can X-ray it, We can listen to it, but whatever we're doing to observe this physical property does not change the substance. A chemical property can only be observed by changing the identity of the substance, because a chemical property relates to a substance's ability to undergo changes that transform it into different substances. Or put another way, a chemical property relates to a substance's chemical reactions, its reactivity. So we can't tell whether or not something will rust until we subject it to being rusted. So we can't tell whether something will burn without burning it. So chemical properties are going to change the identity of the substance. Physical properties, on the other hand, can be observed without changing the identity of the substance. We can see at what temperature something melts, at what temperature something boils. We can measure the density. We can look at color. We can look at texture. We can look at state of matter. All of those are physical properties, and we can measure and observe those without changing the identity of the substance. Because remember, melting something is a physical process. So even though it's changing from a solid to a liquid, it is still the same substance. It's just in a different state of matter. Okay, another way we divide our properties of matter is by talking about extensive and intensive properties. So extensive properties are those properties that depend on the amount of matter that is present. So you can think of the word extent, to what extent. So this depends on how much of something you have. Intensive properties do not depend on the amount of matter present. So some easy examples of extensive properties would be things like volume and mass, and even the amount of energy that something contains. I know this one might be a little bit harder to wrap your heads around, but you guys can think about calories as an example of this. We all know that a bigger bag of chips has more calories in it than a smaller bag of chips. And so by the same token, anything that we have more of is going to have a higher energy content than the same thing if we were to have less of it. Intensive properties, on the other hand, do not depend on the amount of matter present. So melting point, boiling point, density. So those don't depend on the amount of matter present. Doesn't matter how much ice you have, it's still going to melt at 32 degrees Celsius. Or water is going to freeze at 32 degrees Fahrenheit, 0 degrees Celsius. It might take longer to melt. It might take longer for all of it to reach that temperature or for it to boil, but that temperature is going to be the same. So extensive properties depend on the amount of matter that's present. Intensive properties do not. Okay, and then the last thing we'll talk about in chemistry class is the processes of matter. And so we talked about this a little bit when we talked about physical and chemical properties. Physical changes do not change the identity of the substance. Chemical changes do. So examples of physical changes: melting, boiling, breaking something. But a chemical change changes the identity of the substance: rusting or burning. So a classic example of a physical change would be if you crack an egg. You can crack the eggshell. The egg and the shell are all still the same matter that was there before. It's simply that the eggshell is broken. But once you cook that egg, that's a chemical change, and that has changed the identity of the egg. It has changed the proteins in the egg. Okay, so that's about it. As always, if you have any questions, make sure you take a note and let me know, and I look forward to seeing you in class.